In this video, I will show you how to find the increasing and decreasing intervals of functions like this, and I will show you how to find the relative extrema, the local maxima or minima, and I will show you how to justify all of your answers. We can find f prime term by term. The derivative of sine is cosine. The derivative of cosine is negative sine. The negative will come here to the front and turn this into a positive. So we have positive radical 3 sine x. That's it. This is the derivative. Now we need to find the critical numbers that will make f prime equal 0 or make f prime undefined. But there are no values of x that will cause cosine or sine to be undefined. So we don't actually have to worry about this option. So setting f prime equal to 0, we have cosine x plus radical 3 sine x equals 0. Subtracting radical 3 sine x from both sides, we have cosine x is equal to negative radical 3 sine x. Let's divide both sides by sine x. This will give us cotangent x. So we have cotangent x is equal to negative radical 3. Because of course these cancel each other out. I am more comfortable with tangent than I am with cotangent. So I'm going to do the reciprocal of both sides and write tangent x is equal to negative 1 over radical 3. You might be more familiar with this as negative radical 3 over 3. These are the same. Right now you should be asking yourself, what is the reference angle for this equation? Ignore the negative sign for a second. The tangent of what angle is 1 over radical 3, or radical 3 over 3? Hopefully you memorized every value on this chart back in pre-calculus, including the fact that the tangent of pi over 6 is 1 over radical 3. If you haven't memorized these values before now, please pause the video, write this down, study it, and make sure you memorize it. But for right now, tangent of pi over 6 is 1 over radical 3. So that is the reference angle. There are 4 angles on the unit circle that have a reference angle of pi over 6. There's one in every quadrant. The tangent of any of these angles will be some kind of 1 over radical 3. But 2 of them will be positive and 2 of them will be negative. So you needed to know that tangent is positive in the first quadrant and in the third quadrant. Tangent is negative in the second quadrant and the fourth quadrant. We want the tangent of x to equal negative 1 over radical 3. So we want the solutions in the second and fourth quadrant. These angles are 5 pi over 6 and 11 pi over 6. So these are the two critical numbers. We need to put these numbers on the number line and make a sign chart. Make sure you label your sign chart as f prime. I put 0 at the beginning and 2 pi at the end because we are limited to that interval overall. We need to figure out if f prime is positive or negative in each of these intervals. So let's do some test values. What about a value between 0 and 5 pi over 6? So that's between here and here. Well, pi over 2 is on that interval. So cosine of pi over 2, cosine's the x value, so this is 0, plus radical 3. Sine of pi over 2 is 1. So this is going to be positive. What about between 5 pi over 6 and 11 pi over 6? Well, that's between here and here. Pi is in that interval, so let's just use pi. cosine of pi is -1. It's that x value, plus radical 3. Sine of pi is 0 because it's the y value. So that means this term is gone, and we just have -1. So this is a negative value. For this last interval between 11 pi over 6 and 2 pi, it's okay to go ahead and use 2 pi itself. So cosine of 2 pi is 1, and the sine of 2 pi is 0. So that's going to wipe this out, and we're left with +1. So this is a positive value. Because this is the only row on our sine chart, then we really have found that f prime is positive in this interval, negative in this interval, and positive in this interval. That means that the original function f of x is going to be increasing in this interval, decreasing in this interval, and increasing in this interval. So we would say f of x is increasing from 0 to 5 pi over 6 and from 11 pi over 6 to 2 pi because f prime is positive. F of x is decreasing from 5 pi over 6 to 11 pi over 6 because f prime is negative. But we can go further and talk about the relative extrema. Notice that before 5 pi over 6, f of x is increasing. After 5 pi over 6, f of x is decreasing. That tells us that we are looking at a relative max. See how it's at the top of a hill. And then looking at 11 pi over 6, it was decreasing before 11 pi over 6, increasing after 11 pi over 6. So that tells us that we have a relative min here. One thing that you have to be careful about, you cannot mention increasing and decreasing when you justify this. You have to use the first derivative. So we have to go back to the fact that there is a relative max at 5 pi over 6 because f prime goes from positive to negative. That's the way you have to say it. So let's go ahead and write this up. You say f of x has a relative max at x equals 5 pi over 6 because f prime goes from positive to negative. Can you guess what we will say about a relative min? We'll say f of x has a relative min at x equals 11 pi over 6 because f prime goes from negative to positive. Let's find f prime term by term. So the derivative of sine squared, we have to do the chain rule. First we take the derivative of the outer function by putting the 2 in the front. So we leave this inner function of sine x, but then we multiply by the derivative of the inner function, and the derivative of sine is cosine. So that's the derivative of the first term. Moving on to the second term, the derivative of sine is cosine. So that is the derivative. Next, we need to find the critical numbers. These are the values of x that will either cause f prime to equal 0 or be undefined. There are no values of x that will cause cosine or sine to be undefined, so we don't have to worry about this part. So let's just set f prime equal to 0 and solve. I'm noticing that we have cosine in both terms. So let's factor out that common factor, put it out in front of some parentheses, and see what's left on the inside. Well, if we take away the cosine, that's going to leave 2 sine x. And if we divide out this cosine, we're left with 1. Now let's use the zero product property and set each of these factors equal to 0. Subtracting 1 and dividing by 2, we have sine x is equal to -1/2. So we just need to find the solution of both of these, which you should be able to do in your head very quickly. Where will cosine equal 0? Well, cosine is the x value on the unit circle, so the x values will be 0 at the top and at the bottom. So we're talking about x equals pi over 2 and 3 pi over 2. So these will be two critical numbers that we will put on our number line in a minute when we make the sign chart. But what about sine x equals negative 1/2? I encourage you to think in terms of a reference angle. So ignore the negative sign for a second. Sine of what is 1/2? Hopefully you're jumping out of your seat going, pi over 6, we know this. But there are 4 angles that have a reference angle of pi over 6. There's one in every quadrant. Sine of any of these angles will be some kind of 1/2. It's just that 2 of them will be positive and 2 of them will be negative. So we want sine x to equal negative 1/2. What are the 2 quadrants where sine is negative? Well, sine is a y value, so it's going to be negative in these 2 quadrants. So let's focus on that. So these 2 angles are the solutions. This angle in the 3rd quadrant is 7 pi over 6. And this angle in the 4th quadrant is 11 pi over 6. So we have 4 critical numbers to put on the number line to form the sign chart. When you make your sign chart, make sure you label it as f prime. For this problem, we are limited to the interval from 0 to 2 pi, so that will be the beginning and the end of the number line. Also, because we have 2 factors, cosine x and 2 sine x plus 1, we will need 2 rows on this sign chart. Next, we need to decide whether these factors are positive or negative in each interval. Let's start with the blue factor of cosine x. At first, it seems like we are going to need to test 5 separate intervals. However, it's going to be a little bit easier than that. I've color coordinated the critical values to match the factor that they came from. So cosine x is equal to 0 at pi over 2 and 3 pi over 2. That means that these are the only places where cosine x might change signs. Because of that, we only need to check the interval from 0 to pi over 2 and from pi over 2 to 3 pi over 2 and from 3 pi over 2 to 2 pi. Those are the only 3 intervals we need to test. In this first interval, we could pick a test value between 0 and pi over 2, like pi over 4. However, we can also use 0 as a test value. Because this is not a critical value for cosine x, there will be no sign change here. We are allowed to use it. So I'm going to use 0 because it's simpler. Cosine of 0 is positive 1. So cosine x will be positive in this interval. In the middle interval, I could use 7 pi over 6 as a test value. However, I can pick any value between pi over 2 and 3 pi over 2, including pi, which is the easiest. Cosine of pi is negative 1. So cosine will be negative throughout this interval. In fact, for this last interval, let's go even simpler. We know that cosine x is the x value on the unit circle, and between 3 pi over 2 and 2 pi, x values are positive because they are to the right. So cosine x will be positive in this interval. Now let's figure out whether 2 sine x plus 1 is positive or negative in each interval. Again, we don't need to test all 5 intervals separately. 2 sine x plus 1 is equal to 0 at 7 pi over 6 and 11 pi over 6. These are the only 2 places where this factor might change signs. So we only really need to test 3 intervals. The first interval is from 0 to 7 pi over 6, and then we need to test the interval from 7 pi over 6 to 11 pi over 6, and we need to check the interval from 11 pi over 6 to 2 pi. In this first interval, we can use pi over 2 as a test value. At pi over 2, sine, a y value, is 1. So this factor becomes 2 times 1 plus 1. That's positive 3. So this factor is positive in this interval. In the middle interval, we can use 3 pi over 2 as a test value. Sine is negative 1 at 3 pi over 2. So this factor becomes 2 times negative 1 plus 1. That's negative 2 plus 1, which is negative 1. So this factor is negative in this interval. In the last interval, we can use the endpoint of 2 pi as a test value because 2 pi is not a critical value. 2 sine x plus 1 is not equal to 0 here, so there's no sign change, we can use it. At 2 pi, sine is 0. So this is 2 times 0 plus 1, which is plus 1. So this factor is positive in this interval. Now let's decide whether f prime itself is positive or negative in each interval. A positive times a positive is a positive. A negative times a positive is a negative. A negative times a negative is a positive. A positive times a negative is a negative. And a positive times a positive is a positive. Ultimately, we need to figure out where f of x is increasing and decreasing. And we know that f of x will be increasing in these intervals because f prime is positive. And we know that f of x will be decreasing in these intervals because f prime is negative. Let's start with the increasing intervals. F of x is increasing from 0 to pi over 2, and from 7 pi over 6 to 3 pi over 2, and from 11 pi over 6 to 2 pi, because f prime is positive. Don't forget your justification. F of x is decreasing from pi over 2 to 7 pi over 6, and from 3 pi over 2 to 11 pi over 6, because f prime is negative. What about the relative maxima and relative minima? So if you look at my little hints here that I wrote down about f of x increasing and then decreasing, you can tell that there must be a relative max here at pi over 2. But you can't say for a justification that there is a max at pi over 2 because f of x is increasing and decreasing. All the work we've done has been using the first derivative test. So you have to use the first derivative in your justification, like this. You have to say f of x has a relative max at x equals pi over 2 and 3 pi over 2 because f prime goes from positive to negative. Similarly, we can tell because of the increasing and decreasing pattern that there is a relative min at 7 pi over 6 and 11 pi over 6. It's decreasing and then increasing. Obviously, that's the bottom of a little valley. Decreasing, increasing. This is a min. But you can't use the decreasing, increasing argument. You have to say f of x has a relative min at x equals 7 pi over 6 and x equals 11 pi over 6 because f prime goes from negative to positive. I know this is kind of a lot, but you got this.